let's watch the fungi. Let me
Let's
save
watch
this
some
one.
clips.
Let's watch the clip. So this is some clips. Most of these clips Sean put together, but this first one I found as a compliment, as kind of a creepy zombie fungus thing here. And I want to sort of, it's about 10 minutes worth of footage, and we'll sort of listen and pause and talk about a little bit of this stuff. But to me, what really stands out is this idea of the microbiome management, like microbiome and also mycobiome, so the fungal stuff, right? Thinking about connected consciousness and superorganisms, and then also specifically thinking about children in environments. And at some point in this, they talk a little bit about transistors and something called a memristor, which is like a computing system that holds its past memory so that it can go back, and that's something that a fungus, like a slime mold, can do, which they haven't figured out how to make a machine do yet. So they're trying to meld the optimization of biology as a supreme technology with the networking. And I'm wondering if part of the memristor stuff links to the blockchain. If you have ubiquitous sensing and it's all going onto the blockchain, if that holds the state, if you can go back and rewind and go back to that stuff. And then also, Sean, can you say something about that white rot fungus and time? Do you remember enough stuff to say anything about that? I just thought that was different.
I don't know the name. I think I wrote it down, actually. Let's see if I wrote it. It's a white rot fungus, Lebopsis. I don't remember the name. I think we could probably put a link in the talk, but it was on a Department of Energy website, and I was very curious I was sort of like trying to identify what this fungus was on a large fur round that I have that's actually part of our kids' playground. And there's this big patch of fungus that's on it. And I was like, well, what is that? And so I started doing white rot fungus precursory research, and I came across this article. Because the Department of Energy is very interested in sort of doing a fungus or a mushroom genome project. So they're like looking at all of the genes of fungus, particularly as an environmental, I think they called it it's not an insecticide, but they wanted to use it to break down wood.
Okay.
Because one of the problems
lignin,
when
right?
after you do logging, lignin, the wood cellulose.
Right.
And so they found that this mushroom species could express a protein that sort of gamed, or it was an enzyme that tricked the wood into breaking down quicker than it normally would. And so they called it breaking up the wood in time, not in space. And so convincing the wood that more time had passed than it actually passed.
Oh, wow. That's interesting.
But you click on the link and it says you are not authorized to view this page. And I'm like, this is a government website. What did I do? But so just the idea that the mushroom, if it's a symbiosis between the wood and white rot fungus,
right?
Why is it tricking the wood lignin to start to break down? And of course they're interested in that.
So it's communicating
for
something that's false.
It's communicating
something. It's like
something.
a false reality.
Yeah, and so they want to use this for after clear cutting, and like you want to get rid of all this debris that's left without burning it and blah blah blah. But what could be the other applications of tricking a plant or a tree to express an enzyme to help itself break down? I don't know, but that's the gist of it. If that did you any?
But I think that the time scale idea is interesting, and there's something in terms of the chemistry, the chemical language exchange between the fungi and the wood fibers. And it's a language, right? It's a communication system. And one of the things, this woman with this Arise video that Leo had first brought my attention to, and she was talking about the economy of a phosphorus exchange between the fungi and the roots, and that it was supposed to be a mutually beneficial situation, that the fungus was getting something from the root it couldn't make itself, and then the root was getting phosphorus or whatever. But later on in her talk, she essentially says, but actually the fungus can also down-regulate the root and limit its capacity to sustain itself. so that it becomes more dependent on the fungi?
So right now we've got about 3 colors that we can work with. And this allows us to sort of change, for example, we can add the different colors at different times, or we can add the colors at different places in space. And then we can for the first time, sitting at that poker table, kind of understand the strategies that these fungal networks exhibit. So we found that fungi are very good at discriminating among plant roots, right? They can tell a plant that's giving them lots of carbon versus one that's giving them very few carbon. We also know that when you reward fungi with carbon, this triggers more cooperation. So in this case, it provides more nitrogen. The fungus ends up giving more nitrogen to the host root. One of the most interesting ideas is this hypothesis that fungi can actually restrict the autonomy of root systems. So what that means is that the fungi can get into a root system and actually down-regulate the ability of the plant's own nutrient transporters to take up resources from the environment. So basically hijacking the plant's own nutrient uptake system. But that works perfectly for the fungi because then they're getting plenty of carbon and the plant becomes even more dependent on the fungi.
And so I was thinking about that in the context of digital currency and UBI. When they're saying, oh, here the billionaire tech people are going to give you some money, but then, this $1,000 a month so you can pursue your passion and be human in front of the machine. But if we need to, we can change the game mechanics and down-regulate you so that you become more dependent on us for your sustenance. And it seemed like a really logical connection there. And then Will Ruddick, who was working on, again, grassroots economics.
She owns a well and sells the water to her many neighbours every day, but her neighbours don't have money to buy water. During crisis times, each one of Songa's neighbours has something important to offer that other members of the community want and need. There is a new solution called community inclusion currencies. Songa joins a network of farmers, teachers, and small businesses that are trying to create a stable marketplace by trading their goods and services amongst themselves. The network pools their resources, as well as donor assistance from cash and voucher assistance programs, into a community fund. This fund is leveraged to create and back digital community inclusion currency credit. Now she can meet her basic needs by trading them with other community members using her simple phone. Community inclusion currencies are securely and transparently created on the blockchain, backed by community goods and services. Songa, who have limited resources, can come together to trade with their community inclusion currencies even in times of crisis. And they can save their national currency and pull out their community funds for essential imports and building their local economies. That's how community inclusion currencies complements missing national currency. Humanitarian aid organizations, such as the Red Cross, can use economic data to better understand local economies and support vulnerable communities by adding community funds and creating more credit for communities in need. Powerful tools for utilizing their resources to pull themselves out of crisis and poverty.
The whole Arise talk was about permaculture, and not just with the tree roots, but with grassland.
Below our feet. And we're calling those people underground astronauts. We're getting a little bit less funding than space people, but there's still so much to discover. What you're looking at right now is a video that we have been taking, a series of videos of living fungal network. This movement is under fungal control. Right? And so this is in real time. This is not sped up. If we could see what's happening under the ground, this is what you would see. And you see how complex it is. It moves one direction, it moves another, it changes directions. And understanding these strategies is really paramount. Now, these are symbiotic fungal networks. So what they do is they're exchanging carbon that they get from root systems for fungi, for phosphorus that the fungi are foraging for in the soil. Now, there's billions of these hyphae under an acre of forest, and there's tens of billions of these hyphae under an acre of grassland. Now, I think a lot of people don't understand just how much this leads to intense carbon stocks underground. So this is a paper that was in Science in 2019, and it just gives a snapshot of what you're looking at in terms of carbon stocks of tropical rainforests versus tundra underground. So understanding the underground is really paramount to our future.
And so Ruddick's social physics experiment was grassroots economics, right? He just happens to be with the Stanford Linear Particle Accelerator, but then swaps over to work with Leotair and these folks in Kenya doing social physics, right, for their complementary currency. But don't worry, Charles Eisenstein is going to set you up with some beautiful money. It's all going to be some beautiful money backed by things we love,
It's two sides of the same coin. A UBI is like rain, it ensures universal health. And demurrage is like evaporation, it ensures non-stagnation. The third feature is a feature called natural capital-backed currencies. And this is an idea by the philosopher Charles Eisenstein, who said, whatever backs money, people tend to make more of. When gold backed money, there was this intense incentive to mine gold because it was like printing money. In ancient cultures where cattle backed money, there was an overproduction of cattle because that was printing money. And so he said, well, why don't we back money with things that we want to see more of in the world, like pristine forests or clean rivers? And that's a beautiful idea. It's a powerful idea. And that's the third feature called natural capital-backed currencies.
Anyway, it's also interesting. This section is called Biocomputers and Electrical Control of Fungi, Slime, and Plants. And so I did just clip out some of sort of the highlights here. But again, they're talking about, and I've mentioned this in one of my talks that I gave in with Drew, this idea of the cordyceps colonizing the ants and then sort of remote control zombieing the ant to help the cordyceps reproduce in a proper location. And so part of what I was saying about, like, are we an exoskeleton either for our microbiome or for our mitochondria, the plants? Are we is there some other intelligence that's moving us around to get us under the leaf? I mean, I was like, it feels like this could be what's going on. But I don't know that that's all the game, but it feels like it could be some of the game. So let's see. This is someone, Illogical Gates, from February of 2023 about cordyceps and microchips. So we'll play some of this and then talk about it.
Control and use fungi first for our own biosensors and maybe even computation. See, the cordyceps is able to attach to a live ant, get inside the body, and will the ant to move and navigate to a precise location that's optimal for the fungi's liking.
So I think it's interesting, this idea of navigation, to get into something and then to navigate it to a certain location. And I think both of us have been talking about that in our own lived experience.
Yeah.
How did we get to this moment in time? In this place?
Back to the landers, we're going to move you back to the land because, some people are leaving the cities, but not everybody. A lot of people are going to the cities, but yeah.
Right. And so, and again, how did I land in Hot Springs? I mean, people ask me all the time, why did you choose Arkansas? Well, I have rationales for why it felt like the right place, but I don't know. Maybe I'm just supposed to be here. Maybe the tartar on my teeth are telling me to, go to the Crystal City or whatever. Yeah. And so the other piece on the navigation is, again, there's this guy, David DeLorme, who had a connection. He makes these atlases, right? And his company that makes the atlases increasingly went digital, and then the digital goes to GIS. And I think you've talked a little bit about that with permaculture and mapping systems, is that those maps become 4D over time once you get information layers that you can run back and forth. And that he's connected, I think, to a series of books that's dedicated to Steiner about these sort of off-the-grid permaculture communities informed by this Bulgarian mystic, which would be all qualia, right? But it would be navigation and possibly into an interdimensional kind of lattice space.
Yeah, the whole permaculture method is not directly related. It grew out of biodynamics, but Steiner's biodynamic method of farming is the site your land, your parcel is a living organism. That's sort of the fundamental aspects of biodynamics. Whereas permaculture, similarly, we can't control what our neighbors do, but everything within our site or our organism is what permaculture maps out, and when I did my permaculture, it was like over 150 pages of data that you put into a PowerPoint, and it's uploaded on Google Docs. So,
right.
Make that what you will. But everything that I did for Oregon State University to get my certification, it's like, yeah, there's copies of this, and then this is 4D spatial modeling. So now they know way more information about my site than what they can just get with LiDAR or with, conventional GIS data that's available on Clark County's website. Like, I gave them way more,
right.
So now,
and how many people are getting certified? Probably, it's not the majority.
I think it's not a huge amount of people who are, there's not a lot of money in it unless you can take permaculture and sort of apply it to real estate or apply it to the trucking industry, like some people have decided they think they can do. And, so I think that's the permaculture method as a model for different flavors of resiliency, not just, land and soil resiliency, but we're sort of inoculating the whole culture with 400-year thinking. And I think there's a lot more that's being done with permaculture than just land management. And it feels like,
it's the story too around permaculture.
Yeah, and there's a lot of value
and you
to
do
it,
some really
sure,
amazing stuff too, because part of you integrate your creative aspect into engaging with people over food, not in a nefarious way, just in interesting ways, but artifact using story and relationality.
We got to make it fun. If we're going to be on this game board and you're not going to have fun, nobody wants to play with the guy who's like, oh, geez, I hate this game. Well, it's your turn, roll. And I'm like, crap. Well, that's not going to be, and I do have days like that. I think we all do, where, especially in this problem solving area, it's I really get frustrated with it. But yeah, got to have fun with it. So art, humor, and good food and good company is definitely a strategy to enjoy the game, but probably not gonna ever win.
Maybe, but I feel like it's almost one of those cooperative games. When my kid was little, there were those certain cooperative, non-competitive games, and I feel like in Balderdash,
where you get together and lie, and I feel like that's a lot of what it is. Is
I need to go back and look
Balderdash,
at
and I'm I don't have anybody to talk to, so I'm nobody believes me when I try to tell my story.
It's interesting though, because I've had several people reach out to me recently, and I don't know what to do now because I know these things. I've been exposed to this information, right? And I'm not telling everybody that I'm right or that my hypothesis is the only one. But once you wade into it and you're like, oh yeah, there's some stuff going on here, right? But then you don't actually have enough people to talk with it about. It is actually hard.
Yeah, in between the conversations that we have, it's not a lot of people that can grasp this stuff. So then the best thing to do, I think, is just keep reading the rule book. And that'll occupy your time until you find...
Look for sculpture, look for fungi.
Look for sculpture. Those signals and the trail is out there to lead us to at least to enjoying the path that we're on if we remain somewhat optimistic. It's
well,
it's
I think looking at it as a game, and again, it doesn't mean that we have to always be happy that we're in the game, but I think it's less stressful on the psyche to you try out that frame than there's an amorphous, predatory, scary thing sucking the soul out of you and there's nothing you can do about it. To me, that doesn't feel like such, there's... Anyway,
or even in a game, though, the problem with the game is that there's winners and losers, and you use that metaphor a lot, and then I kind of came up with it on accident. We were talking about entrainment. It's a play, or like I said, a musical performance.
Yes, I think so.
We're all
Gilbert and Sullivan
singing this song, or we're all playing a musical instrument in a circle, and the least we could do is figure out what song we're singing, or what where the song, if it's oral tradition, what is the meaning of the song?
Right.
What are the lyrics, and why is the song being passed down to us? And, just getting in and singing the song without asking yourself what the song means, that's okay too. But then there's a lot of
people who just who won't think about twice about it. I
mean,
and I guess that's
they used
how
to do
it is.
mass in Latin, and I feel like, if we're going through an awakening, then we're finally able to interpret it, because most people don't speak Latin. And so now, like, some of us are learning Latin. A new language, a universal language that's being like, they're,
And it's a little painful. Like, I've had a few comments. People are like, can you talk slower? Can you do it shorter? And I'm like, I can only do it how I can do it. And I feel like you're offering in the same spirit. We're laying material out and then riff off of it. Hopefully you're not going to misinterpret things, but we can't do all the things. We can just we're not intentionally trying to be, difficult about it. It's just, we can only engage with it from our perspective. So let's see.
The fungi appears to mind control the ant, though research indicates this is more likely actually muscle control, though it's still wild to consider that the slow-moving fungi is capable of quick decisions or computations to navigate a relatively fast-moving ant. Now, the interesting part is where exactly the fungi walks the ant to. The location is generally an optimal humidity, and temperature for fungi growth is usually 10 inches off the ground, and it's upside down under a leaf on the north side of the plant. Take a second to think about that. Again, the fungi controls the ant to such a precise set of environmental conditions, and this keys us in on remarkable sensory abilities of the fungi.
So I think that's pretty interesting. And they go on to talk about sort of magnetoreception, the avian magneto, but also, I guess, fungal, and the electromagnetism. So again, the steering, right? Kubernetes, we're back to cybernetics, but maybe we're not just being steered by our smart watch, but there's some other consciousness.
Yeah. I don't know if this is a good time to share what happened to my compost pile this year,
no.
But so it's kind of a joke, but so there's another fungus called morels. A lot of people know what morels are. They look like the brain fungus, and they're very difficult to cultivate, and you have to sort of hunt for them in the wild. But they will grow in places. And so this year we get this huge flourish of morels in our compost pile. And it was kind of a neat surprise. But I put everything in the compost pile. So it's like clothes, like cotton clothes, and eggs that didn't hatch, so there's some animal elements there. And so it's like, well, where did the spores for the morels actually come from? Did they come from my old genes? Did they come from another life form, like a partially developed chick fetus? So is it, is it morgellons or is it morellins? Is the morels already in me? And, and then the right environment occurred. It's it was sort of mysterious to see all these morels just sort of poof. And then they're only place on our property that I've ever seen them. And they've been there for 8 years. So the fact that they grew out of the compost pile.
But what if you logged everything that went in? What if it was some recipe?
I'm sure that would be in the next chapter in the permaculture method.
I'm not recommending that you do that, but it's interesting computationally because it was literally an emergence.
It was, and it was an emergence
of a complex system.
Non-natural ingredients, or however you define natural. I don't feel like cotton textiles are natural in the natural environment. Right. So was it?
You were doing innovative experimentation with your compost pile.
Yeah, or it was experimenting on me, right? And be like, how do I get to the next stage that I'm now upping my compost game? Because I don't know if they did this in Philadelphia, but did they give you a trash can?
Oh yeah.
Do you have your blue can for recycling in our municipality, and then you have your gray can for garbage, and then you have the green can for yard waste? Did they do that?
Well, we don't have yard waste in downtown, but yeah.
Yeah. Well, even in Portland, when I lived in Portland, it was this big thing, and so they wanted everybody's food scraps and yard waste and all of that stuff, so they could take that and then do this big giant composting project. And then they would use that compost all over the city for city works projects. But that was like composting 10 years ago. Now I'm like composting everything that you can.
Yeah.
And I don't know. what composting
Well, we had the
is.
recycle bank points. We didn't have the compost part, but Wharton introduced the scan that you would get community credits for recycling. And now nobody recycled because they got community credits, but it was prototyping these early community banking sustainable behavior things. And then eventually they wound down the program and everyone had a bazillion points that they never used because that's not why they recycled. And then they had them. It's interesting because they had encouraged everyone to give them to the public schools to do community gardening programs. So that's an interesting.
Again, and then you're in the garden again,
and then you're back in the garden.
Taking all of this compost, which is essentially microbiome and mycobiomes and all this different stuff, and then you're bringing it all together, sort of homogenizing it, and then spreading it out in a new terrain to inoculate, and what's in that compost that they want to then spread out and inoculate all over the public commons in particular.
Right. Do you want to say something briefly about the Washington State's foray into sustainable funeral arrangements?
Oh, I feel like that could be a whole.
We'll do a whole separate one, but just touch briefly on, because in the tardigrades, I feel like are part of it too.
Yeah, well, so it's natural organic reduction, NOR. So I'll say it again for those at home that are listening to look it up. Natural organic reduction. Washington State was the first state to legalize this, and it's human composting. And you can see there's a lot of stuff that's been written on it. I believe Colorado has legalized it. California, it'll take place in 2027. It's coming in online, and there's a few other states, I think 9 now, that have done it. But it's relatively new, and this is different than water bath cremation, and it's different than alkaline hydrolysis, which is what they do to farm animals, which is a more aggressive water bath. This is mixing a human body with wood chips, alfalfa, and straw, and putting them in a vessel and leaving them there for 4 to 6 weeks and flipping the vessel over. And the temperature never rises above 130 degrees. So that's super important for, keeping certain things alive. When you talk about the
microbiome,
natural fungus that's already in the inoculating material, like the sterile material, but then whatever's in the body.
Human anymore at the end of this process. At the end of the process, you cease to be human.
The climate crisis at some fundamental level is a soil crisis.
Fully embracing myself is organic matter, just something to rot and decay. You've always seen Recompose as a combination of ritual and science and technology. Sometimes that dichotomy is a lot of fun. This is like a spaceship, but also it's like the forest floor. So I get really kind of nerded out about that. It's like the forest floor in space. In a spaceship. Think about it, bro. Whoa. We're going to start with the ritual aspect of it, which is the laying in ceremony. But what we want to do is set up the opportunities as much as possible for that extra participation. And so what we've done thus far at Recompose is make the sort of practical piece of it. The body is out here and it needs to go into the vessel. How can we make sure we mark that moment and turn that moment into a ritual? Purely air is being pumped through. So you're actually probably pretty warm, cozy, comfortable, and got plenty of air to breathe. Dead, you decompose and turn into soil, and those are sort of your only two options. So true. So right now, as we speak, we have those microbes on us. They're in the wood chips, they're in the air. And so you're absolutely right. The only thing that makes that process start is the fact of the dead. These essentially hundreds of pounds of soil. So 50% of our families come here with a trailer or a truck, and we put that cubic yard of soil, which is several hundred pounds, into that truck, and off they go.
For 30 days, the body and plant material get cozy in the vessel, letting those hungry microbes get to work breaking down the organic matter. The composting process breaks down most bones, but if there are fragments remaining larger than 1 centimeter, they are processed in a cremulator. The soil is then allowed to cure before it can be used in gardens, forests, or conservation land. Sometimes mushrooms even grow from the soil at this stage.
Fills the ground with good things that help make new trees grow.
Here at Bell's Mountain, after over a century of continual clear cutting and no restoration, the soil was depleted. If only there was some kind of nutrient-dense soil to repair the land.
This is Elliot Rasnick, the director of the nonprofit here. So this is it.
This is it. This is almost all of the soil that has been brought here. We've welcomed 28 people onto site, standing roughly in the middle of the first restoration project that we know of to be using soil made from people to supercharge its impact. So salmon face so many threats, but one of the most significant threats that salmon face is that they only spawn in cold water. And so as the planet increasingly warms, cold water for salmon to spawn is increasingly threatened.
With this restoration project, you are trying to get rid of invasive species along the stream and replace it with native species that will shade it. So with your dead body, you're supercharging conifers to provide a canopy for salmon to comfortably breed in cool water. That's so romantic.
Isn't it?
We kind of get stuck on the idea of, I'm gonna be a tree, which they are. Quite literally, they're gonna boost up a conifer, but it's so much more than that.
That's right, and I think part of the incredible genius of what Recompose is up to is that it's not, your body isn't in one particular place, right? We saw the pile of soil is commingled of many, many people. So you're not a tree, you're a forest.
You're not a tree, you're a forest. No green death care option can solve climate change. But mentally, I think there's something that happens when you choose this.
My sense is that the climate crisis at some fundamental level is a soil crisis. There isn't the soil on this planet right now to hold the carbon that plants can sequester. And so the possibility of a transformation of our relationship with biomass and the scariest biomass to think about using for life is our own bodies. And if we can change the way we think about how we use this biomass, if we can honor the end of this biomass as necessarily something to be used for good, to build up the soil, then I think we do stand a chance to, at some level, mitigate what's coming.
Information.
So if we are filled with
like that.
Information, and if we have any sort of nano sensors or any sort of stuff in us, they say that you're not allowed to do the natural organic reduction if you have a prion disease, like Huntington's disease, Crutchfield-Jacobs, some of the other known prion diseases. But again, this starts getting way off into the weeds. But what are prions?
Right.
And is Alzheimer's, and are there other prions that science hasn't identified yet? And so are they really doing what they say they're doing? And then, of course, there's where do we take the compost, right? So if this is, right, because it's not just like, it's like a cup of dirt. No, it's half a yard to a yard of soil, which is a lot of wheelbarrow loads if you know how much a yard of soil is. And then most people don't have room for a yard of soil if they live in the city, right, and they did the right thing, composting the green method. So then where does the soil go, right? And so then we set up this land trust called Bell's Mountain / Rememberland, and they're the official receiver of natural organic compost in the state of Washington that's partnered with this company called Recompose, and Recompose is out of Seattle. And ironically, it was your magazine, college alumni magazine, and I can't remember her name. I want to say it was Cheryl something, but the lady that drafted the regulation for Recompose is from Wake Forest University.
Oh,
no
forest.
No pun intended there.
I didn't even think about the forest.
University,
right?
Yeah, Wake Forest. And so they worked on this for like over 10 years.
Wake
and
is
a wake,
funeral, but also wake is in water.
Yeah. Like, oh, there you go, wake in water. I didn't even think of that.
Wow.
But they worked really hard on this stuff. So here you have North Carolina, Wake Forest University, and this lady's helping craft the policy.
With R.J. Reynolds, who had these ties to Zeitz, who was working on prions with RJR money.
Yeah. I mean, it gets very, it's a web. It's definitely a mycelia web.
Yeah, we'll get back to it in more detail. But I mean, it's
I feel like we could do a whole talk on it.
Like, we'll do a whole talk. Yeah, we'll definitely. But this idea of compost, it gets even more when you talk about non-traditional elements in compost, right? Like Washington State is, leading the way in this, and in the name of sustainability and re-indigenizing in some ways, because this place has these connections to
it has there's so many different partnerships. It's really hard to unravel it. And, it's connected to a much, much bigger land trust sort of group called Forterra, which was the Cascade Policy Institute. And so when you get into the big money in sustainability and clean tech in the Seattle and Tacoma and the Northwest in general, like there's the University of Washington's involved, the Department of Natural Resources is involved. There's a lot going on that I'm sort of like actively trying to piece it together. Yeah. But the compost, if we just say we're taking compost, human cremated compost, and then mixing it into a pristine environment, what sort of
with maybe particular geological features, right? Did you not say that location?
Yeah, there's some geology there. It's well, the water's coming out of, so if a compost slowly moves into a watershed, and then that water carries the information that's in the compost, I don't know. I have like probably a half dozen different hypothetical things that could be going on up there in Bell's Mountain. And we'll see.
But most people wouldn't think to mix in this idea of the microbiome and permaculture and information theory and the noosphere. And
except the board members of Rememberland, who one of them was the heir of the FTX refrigerated trucking industry, and she's actively looking to bring permaculture principles into the trucking industry. And I think that was in 2013, she did this article. And so what is that? It was like, well, we need some truckers to backhaul cremated human compost and get them up to this land site. And that's a carbon credit, right? So we have to figure out a way to make money with this, because you're taking the cremated humans and then putting them into the soil as a carbon store. Again, remember, they're demonizing, or it's probably the wrong word. They're looking at traditional funerals and burials as a carbon problem. And so Troy Hoddle, who is the think tank guy who's affiliated with these groups, he's the carbon expert who calculated how much carbon a funeral takes if you're going to embalm and bury, or if you're going to do cremation, which most people are cremating now, as opposed to human composting. But what they don't say is, well, what about the backhaul? And you have to transport the body, so there's a carbon impact there, and then putting the carbon in the ground. But then is there something else going on with the human carbon, carbon nanotubes, that then those sensors are in the ground? And then there's also the phosphorus aspect of it, because the bones don't compost. Bones don't compost. So they have to grind the bones up and turn it into basically pulverized, powdered crystal phosphorus. Wow. Then they mix that back in with your cremated remains. And so there's a nutrient aspect that they're putting into the soil.
Well, and in the Arise talk, the woman was saying, she was saying that, 80% of the phosphorus in our bones have been processed through a fungal network.
Wow.
Right. And then she has these different, 3D versions. So if you think about it as information, and again, we are all one, and this, like how much phosphorus recycling is there, going on in terms of information in our microbiome and in our biology. And then I was even thinking about the tardigrades. They were introducing it into stem cells, human stem cells, that's in your bones, right? And so what is having
your marrow, your marrow, the myelinated.
Marrow? Imagine that all of a sudden you have composted humans that are chimera human, tardigrade, radiation-proof superhumans. I mean,
and then we're going to grow a table with them, right? As Freeman Dyson says, we're going to grow tables with this stuff. And I'm like, I don't think they're going to grow tables if Research Triangle in North Carolina in Biomason, which is the company that Troy Hoddle is affiliated with, Biomason, I don't think they're growing. Biomason is interested in this specifically for military applications, because transporting concrete, when you do a forward base in a military situation, moving the concrete to set up fortifications and put posts in the ground. So what if we could grow our own concrete? That's sort of the premise of Biomason.
Wow.
So on the one hand, got to reduce our carbon footprint and get all of the people to compost themselves. But on the other hand, we'd
like to use them to maybe make some
to make a military base. Do your part of the Athenian super state. Yeah.
Well, and I think this might be a useful time. It's not exactly related, but Stephers had brought to my attention, our attention, this idea of building biological smart fungal systems, like modular systems that have mycelia in them, that could be doing computation in the name of smart buildings. But because the mycelium can't live indefinitely, that you would dose them with nanoparticles to create nanowires. And this is touched on a little bit in one of these videos, so that when it died back, you still had the network connections that the consciousness of the fungal systems made. So you would have the memory, remember land, right? Mm-hmm. And so you would have the memory of the fungal system in the nano. And so, we've all been looking at Foster Coulson and the Coulson family of wildfire fighting that's in bed with the U.S. Air Force, right? And is doing all of this wildfire spraying, not just scooping water, but also other chemical systems. Like, what is going on in British Columbia? So we talked about the Pacific Northwest and the water and the fungi and what that might mean for Portland and Intel and Seattle and Microsoft and Amazon and the role of that core area, but also British Columbia and Vancouver, and then the forest surrounding that as this networked, wet, moist, nodal system. I don't understand why they're dumping all this fire retardant on the forests that are nowhere near living communities, right? Because up there, it's not like in Colorado where you've got rich vacation cabins, right? This is a remote area. Why would you be dumping? Why would you not just let nature take its course if there's a fire there? Even though, I know there's a lot of questions about the geoengineering and directed energy weapons and how natural these fires actually are. But if you understood, and you've raised, and this is one of these clips, that at least 10 or 15 years ago, they were already publicly talking about creating these fungal computers with nanoparticles. Well, why wait to put them in a smart building when you could turn the whole forest into a computing system? If you're dumping nano onto these forests in remote areas, and then again, what is the Coulson family's connection to that? They're also funding gaming enterprises in the town that they're living in. They're also funding community foundations and now wellness. So anyway, it's really complicated, but kudos to Stephers for reminding us about these entangled fungal nanoparticle computers, because the future of computing looks gushy. Gooey and gushy. All right, so let me play this a little bit more.
It's some sort of automated computation that takes sensory inputs in and is able to decide or compute when all these conditions are roughly met. These specific sensory input capabilities are measuring temperature, humidity, height, and cardinal direction somehow when it knows to be on the north side of the plant. All of these are useful senses even to us humans. That north side of the plant one is most interesting to me, as it likely is detecting magnetic fields to determine that. So that ability for an organism to detect Earth's magnetic fields, it has a name. It's called magnetoreception. Birds actually use it to know where to migrate throughout the year. Even if we could direct that computation and sensing ability, how would we extract the information?
Okay, so that, I didn't actually speed that up, but that was a lot of information. But they're talking about, you had mentioned this before, environmental conditions, using ubiquitous sensing to get optimal environmental conditions for reproduction of the fungi. And so I'm thinking a lot about how this overlaps with Leo's work in satellite sensing, natural capital, carbon systems, the weather derivatives.
And how that fits into agriculture, because I think some of, in an email Leo had shared, there was a lot of just, getting the sensors into the soil.
Yeah.
And then, of course, the soil, and being able to control nutrient uptake and
or not.
There's the
control it, yeah.
There's like Christopher Voigt and the Pivot Bio company, where they have this product that you apply. It's basically like a smart mycorrhiza, right? If people know what mycorrhiza is, it's the natural fungus that tells the roots what to do to bring nutrients into the plant. But so if we could have a smart mycorrhiza, which is essentially how I understand it, then you'd also want to have the ubiquitous sensing to know what's going on all over the environment to sort of get your crops in line with that same mentality, right? So it could be like trees are a harvestable resource. They take 150 years to grow here. And, they have an antenna-like function, transistor-like function. Yeah. But then if they're inoculated with that smart mycorrhiza, synthetic nanoparticle type material as well, then we'd have a way to sort of speed up the growth of the trees for harvest. That is a simple commodification of the application of why they're spraying that stuff in a non-populated area. From a geoengineering, just straight capitalism, speed up the trees, make the trees grow faster, increase the yield, right? But then is there something else that could be going on too? And that's where that intelligence component comes in. Can we use the World Wide Web to run an algorithm and solve a problem for us that we couldn't do with even our most advanced supercomputers?
Or can we tap into the white rot fungus and change the time scale or something like that?
Right. If we can figure out what the enzyme is, then we can take all of these people and then just make them sleep until 2057 when DARPA's going to have us all up in the moon anyway. But I feel like there's definitely something in there.
It's very interesting and how it fits in with the crop insurance, and that you've got to get all of the global south online. And I mean, even, and this is something I haven't had a chance to go deeply into, but Stephers shared a bunch of stuff on fungal melanin, and that the fungi have their own melanin. They can't do their own photosynthesis, but they have their own optical materials that are being used, quote unquote, for sustainable dye stuffs, fabric dyes and that sort of thing. And just thinking about, again, jump-starting all of the global south into the digital economy so they all have wallets, so that their culture, which is often more intrinsically linked to land, in these spiritual traditions, all get fed into the machine learning system even faster.
Just like all biological systems, including plants, this signaling is detectable as voltage spikes with probes, where a separate computer analyzes the voltage spike patterns in a human brain and then attempts to interpret the signal as a given motor action or thought, like moving an arm or a leg. So just like that, researchers or anyone can insert probes into the fungi material and measure various patterns of...
Wait a minute, did you see Elon Musk in there?
I did see that.
I didn't put that in there. I didn't put that in there.
I don't... No, that's edited into this. That's
but I didn't see it the first time when I recorded it. That's really odd. Yeah. So because Stephers had even said, so what is the name of the sort of the Amanita
muscaria is the fly agaric. It's the red mushroom with the white spots, and you'll see it in tons of children's books. It's all over the place as a neurolinguistic program, sort of a it's more than a symbol. It's definitely something going on there with the soma.
Right. And so, I mean, and Stephers made the observation, she's like, I can't help it when I see Musk think, is this a hat tip, to...
But to the muscaria.
Muscaria, yeah.
And then of course, in that
it's in that. Like, I didn't see it before.
Well, he was smoking a reefer in that one, and that's the famous
the cannabis.
Meme. That's the cannabis, the mimetic mind thing, because everybody's seen that picture by now. If you're on the internet at all, you've seen that shot of Mr. Muscaria.
Wow. Well, and so I think, and this is what I want to point out, like when I was talking about grassroots economics, complementary currency, Will Ruddick, social physics, is that what they're saying is, can we harvest the fungus to do computing for us, right? But I think the inverse could also be happening. Like maybe is it a fungus? Is it an interdimensional biofilm? I don't know. But could it harness us to do computation, qualitative computation that it could not do by itself, right? Just like the fungus can't do photosynthesis, so it uses the root, and the root needs the phosphorus. Like, is there something that, again, without our consent or knowledge, we're participating in? When they're saying, looking at the voltage spikes in the fungus, that's how they determine the computation. That's the signal, is monitoring the very consistent voltage, the spikes in the voltage. What if you get everybody online with a digital identity, trading digital currency? You could monitor through, now they're going to make it the World Bank or Central Bank digital currency or Federal Reserve. that's in my opinion, that it's going to be much more likely the community-based currencies that's going to be the signaling, because that's a more diverse, interesting signal. But could you have the system set up to monitor the voltage spikes in the social computation? Is that how it's going to happen through the token trading? Some of which may represent actual money, and then some of it may represent behavior.
And how that fits into the group meditation, or getting people to, can a bunch of people all doing yoga on a Zoom call all at once?
Right.
Can a voltage spike be measured as people enter that state of
That's interesting.
Transcendental sort of?
Well, and again, even yoga and, the shamanic, like the Santo Daime stuff, which was like music and dance and ayahuasca, right? And all of those groups went online. And
without a second doubt,
right?
Without considering like what technology component is,
right? And I mean, we're doing it too, so I'm not like pointing fingers and saying bad, but like you would imagine that if they wanted a qualitative experience based in the environment, based in someone, based in a practice that involved plant medicine linked to specific locations and the people's consciousness, you want to put that on Zoom. That's gold, for this.
Oh yeah. And then they become so much more suggestible when you're sort of like now I'm looking at a screen, my gaze is sort of completely hypnotized, whether I'm on hallucinogenic or psychoactive or I'm just here sober, I'm still this is where I am,
right.
And so imagine if you are sort of having a mystical experience and religious
even the entrainment
interaction through the technology.
Wow. Because one of the early videos I saw with Heckman was a young guy from MIT, and he was talking about using the camera itself. It can blink off the back of your eyeball and get your pulse rate. So they were saying it within the context of online learning, which for the most part, kids zone out and they're not engaged. But they could tell by their pulse rate the level of, Gates had these galvanic skin monitors, but they could also just bounce the light off the back of your eyeball. And so all the parents who were concerned about cameras and surveillance in schools weren't thinking about the Chromebooks. But like I'd seen the video, so I knew like, hey, they know how excited you are about what you're doing or if you're gone. And so apply that into a meditative or a mystical experience, and they've got the spikes. They're able to get those spikes recorded.
Again, how you could send a signal electrically, image based or otherwise, to bring that attention back to what we're doing, since our attention wanders, especially when you're a kid, so you gotta flash something or show something or send
like
a signal.
Elon Musk. I can't believe that.
Like
that was
Elon
just,
Musk.
I did not
to
see that.
To re-engage the young person, right? Because if the young person's sort of squirreling away, attention deficit or whatever, and you're, how do I bring them back to keep them problem solving or coding? Keep doing your game on your iPad.
Saw that when I was doing my early education work, the standardized tests, when they went digital, they would have personalized. So like if you were a 10-year-old boy, maybe the reading response question would involve Nike tennis shoes or something like that. Yeah. And they would give you a personalized question based on something that was aligned to your perceived archetypal interest area to keep you engaged at a deeper level.
Or your entire recorded memory or everything that has a data point, so that what it can remember about you, so then it can say, send them a signal that says this,
Right. And I didn't know.
We're talking about mushrooms, and now there's Elon Musk smoking a joint, and it's just like, embedded in a supposedly scientific video. But
I know it's some
myriad of signals.
Low voltage spikes. If you want to hear in music form what the current decision-making
Okay, so this is the music part, and this is where we get back to like the Goldbug book that I've been looking at and the Gödel, Escher, Bach. And I'm frustrated because I have several, like, I'm not good at math and I'm not good at music. I know it's important. And so I keep hoping that people who have the gifts in these areas can help me figure out, because it is a language, and what they're saying is, how do we interpret this information? Okay. And so what my takeaway is, you can translate the mathematics of the vibratory signals and the spikes into an understandable framework for us, which might look like an electronica musical score, right? And so in that way, I feel like the synesthesia, which Stephers has talked about, and also neurodiversity, which we've talked about before, finding a way to interpret the information from the field in a way that has meaning, that there's a difference between information and knowledge. And so this music is maybe a new way, a new language structure.
Process of a fungi might sound like, well, look no further than Mycelium, who's taken various types of fungus and hooked up probes that measures the voltages within the fungi that we just discussed to amplify ambient voltage spikes that the fungi are producing, and then he synthesizes them to make and mix fungi music.
So it's interesting because, I used to work at a public botanic garden in Philadelphia, and early on, I want to say it's maybe 8 to 10 years ago, we had a relationship with a nonprofit called Data Garden. And they came into the garden, which is a historic 18th century garden in a highly industrialized, low-income neighborhood in Southwest Philadelphia. And it was definitely a hipster kind of event, right? And so they set up sort of pop-up art kind of installation spaces with sensors, now not on fungi, this was on plants, and then created data profiles of the communications of the plants, which I guess is Cleve Baxter-ish, right? Mm-hmm. That everyone could come in and enjoy and like have a pop-up beer garden, in a, some sort of hoagie or something like that. And it was like a thing, right? And it was a novelty. But for the most part, none of us would have guessed that maybe it was connected to a future of like wetware computation.
Data Garden is an arts collective making advances in media technology and distribution. In 2012, Data Garden premiered Quartet at the Philadelphia Museum of Art. This installation made use of natural biorhythms of tropical plants to control synthesizers in real time, creating an immersive audio environment. This acclaimed work gave us the opportunity to tour across North America and share it through public installations, lectures, and workshops on plant sonification. We receive countless questions from all over the world about the activities of plants, their response to different stimuli, and how these affect the music they generate. But Data Garden cannot answer them alone. MIDI Sprout is a biofeedback to MIDI converter that will allow anyone with a synthesizer or a computer to easily convert the biorhythms of plants and even their own bodies into music. We have developed a prototype for artists and collaborators for use in installations and performances, but we need additional funding to make the final product and get it out to people like you. We believe in the positive effects of biofeedback art on people. Creating generative electronic music from your houseplants can enhance your awareness of the world around you. Incorporating plants into musical performance can also generate ideas that humans could never produce, providing endless inspiration. This is the beginning of the global DIY biofeedback movement, and we want you to be a part of it. Support the MIDI Sprout today.
The very sounds you're hearing here are achieved by mapping different sounds to different waves of amplitudes of voltages that the fungi are producing. And Mycelium has even a 10-minute arrangement of what he calls the cordyceps playing the modular synth, which is produced by that cordyceps species, which is a very close species to the zombie ant fungi. So it isn't just artists measuring and using fungi. There are multiple researchers looking into the electrical and computational potential of fungi, like Professor Andrew Adamatsky, who is the director of the Unconventional Computating Laboratory and has published papers on this very subject. One was titled, quote, Towards Fungal Computers, and Dr. Mohammed Mahdi Deshibi, and I apologize for any mispronunciations. He has published research with titles such as Electrical Activity of Fungi, Spikes Detection, and Complexity Analysis. By changing the environmental conditions, we can reprogram a geometry and a theoretical structure of the graphics of mycelium networks, and then use the electrical activity of the fungi to create computing circuits.
Okay, so I just want to pause here because this is an interesting thing to me. So we know that in the pandemic preparedness framework, One Health is part of it, right? People's relationship to the environment and the environment's relationship to people. And it's framed as we have to be careful because climate change and the environment's going to kill us and we're going to hurt the animals. And so we all have to be separate. I think if we also think about humans as sensing objects, things that are sensing conditions and feeding back just like a mycelial structure. And then we think about geoengineering, we think about weather prediction modeling, We think about hedge fund prediction, risk management. We think about crystal lattices and navigation. Like there's a lot in here. I'm just going to reread it. By changing the environmental conditions, we can reprogram a geometry and a theoretical structure of the graphics of mycelium networks, and then use the electrical activity of the fungi to create computing circuits. And so I'm looking at reprogramming a geometry within the crystalline stuff. The graphics of mycelium networks, Michael Zargham often talks about representing people as social graphs. So if he's saying a graphic of a mycelium, is that so different from a social graph of a person created on Facebook? And then mapping the electrical activity would be digital currency transactions at different social levels, like fractally, and then to create the circuits. Do you see that stuff in there too? I don't know exactly what to make of it, but
I see it differently.
Okay.
I mean, and I think I shared this analogy to you before, and this is probably an oversimplification of what's written here, but the idea of a social credit score, which gets a lot of bad play, social credit score. Ooh. Yeah. But no, it's a musical score, right? And so
I forgot about that.
If my behavior or my environment is creating bad behavior, so I need to change my score. Right. I'm not going to change my score. We're going to reprogram the geometry or the physical space, your physical choices, and a theoretical structure of the graphics of the mycelium network. The composting thing is like, instead of just having one trash can, now you have 3 trash cans that you have to use when you take your garbage out. And we have this alternating schedule, and how well you can use your trash cans is really like, your behavior in which represents this graph, and so you want people, the way good music sounds, it doesn't sound like this. It has
a flow,
and there's going to be high notes, low notes, and a crescendo. And so that's kind of how I look at a score.
And then we go back to Matthias, right, and the Aristotelian, the dramatic arc. Like if you imagine the drama as a musical score, right, an opera, like you can,
and then interlay that with this quote, right, and like if there's a way to do that without convoluting it too much, but it's that, how do we encourage people to make their choices better? We can't
the topology,
tell them what to do. That's that authoritarian top-down thing. People don't want to be told what to do. They have to be given choices so they feel empowered when they're making their choice. Like the composting thing that you just shared, people composted and recycled because it makes sense.
Yeah.
We don't necessarily have to incentivize it, but we do have to provide the geometry, right? So we have to give you another trash can that's just for recycling. Otherwise, you're not going to do it.
If you have to go to Home Depot and get a 5-gallon bucket and they haven't given it to you, the participation level is going to go way down.
Goes way down. Yeah, exactly. Yeah. Exactly. And so like a point system that doesn't actually mean anything, but it's a point system in the mind. And of course, it's like, oh, I want more points.
Right.
Like I actually did this to my younger brothers when they were little. I convinced them, they're identical twins. And so I have 3 years ahead of them. I'd be like, I want your dessert, Matthew. And if you give me your dessert, you'll get more points than Andrew. And like, it's a totally made up point system that I manipulated the crap out of my younger brothers with, which I paid for later. They figured it out and they turned on me. But at the time it worked.
There's 2 of them and only one.
A fake system, tokens. Here's some tokens
right.
for your behavior. And so it's reprogramming the geometry is the shape, the vessel, the cup, the container, the space. And then what the mycelial network does in that space, that's like the slime mold, it's going to find its way through the maze one way or the other.
Right.
So we might as well make the maze more efficient or make the maze serve a higher goal of insurance risk, is that for capitalism, et cetera.
Could the reprogramming also be a computational shift? Say we play a game to a point that we've achieved some resolution of the information that's needed at that point. Is there a reset? We literally keep talking about the great reset. Is there some way of clearing the field so that you're reusable as a computational system? Am I being erased and reset?
Like a flush.
You know?
Well, and when we grow mushrooms, we have to sterilize the substrate, right? So if we're gonna like do like a traditional block mushroom for culinary use, we take sawdust as an inoculate sterile substrate, but you have to sterilize it. So that would be like a reset, sterilization. And then, what that would look like in our society would be like a great reset. And we're going to, cook everything or bake everything or make it plain and clean. How would we do that in a societal way? It wouldn't be the same as just putting it in the oven and cooking it at 250 degrees. We'd have to lock everybody in their houses and spin out a narrative that tells us we have to be separate. And then, 18 months later, depending on where you are, what state you're in, like now all of a sudden we have a completely new geometry that we exist in. And we still exist in today. And I feel like that's part of it. And then within that great reset, then you still have all these splinter narratives, these other geometries that, people can be kind of boxed into that are still in that broader reset, so that
framework, or maybe looping, the tentacles back around, like we'll meet you on the other side of the tree trunk. The Joe Rogan.
That sounds better.
Yeah, right.
Joe Rogan's over there behind the tree trunk, and on the way you'll
over
see
here with Paul Stamets.
Yeah,
like we're
Paul
all
Stamets is over there.
Right.
But the geometry.
What's Mr. Bush?
So
Zach, we got a bush. We have kind of crazy.
Provided certain controlled stimulus, scientists hope that
controlled stimulus, right? The stimulus package. We can have a stimulus package.
They can use the electrical activity properties within the fungus and map these complex electrical signals to meaningful interpretations.
So that's the pattern recognition, right? If what Stephers was saying about qualia, what I was thinking about the two-brain corvids, one half of the job is to go out and get the environmental signal and be like, to the octopus tentacle, here you go, here you go, here you go, and then there's an integration that's finding the pattern. And then I kind of wonder about the whole integral theory and the Ken Wilber side of things. Is the integration part of this, even though we're all one, the consolidation of us being the sensors somewhere.
Well, we're one, but Ken Wilber, it's two hemispheres, so east, west, left brain, right brain. It's all the same brain, but one side of the brain is associated with processing certain type of information. The other side, left brain, right brain thinking. Yeah,
again, we've got the ant computer, now we have the mycelium computer, and maybe with the cordyceps, we have them both, right? We have the fungal ant computer.
The symbiosis.
The steerable ant computer.
Which they hope can be utilized to somehow develop computing measures. Determining which part of the embodied system is doing the computation is still somewhat ill-defined. Now, as ridiculous as it sounds to use fungal tissues as part of a computational system, if you break down a current computer to its simplest part, there's little to no intelligence in the individual transistors, for instance.
And so to me, this feels like the ant computer. There's no actual intelligence in the individual units. It's how they work collectively.
Or like the World Wide Web.
Yeah.
Each single tree is just one transistor, but you need a microarray or a forest to create enough power. I don't know, just a thought.
Yeah, no, I like that.
Predictable behavior of the material, given certain environmental conditions and voltage inputs. So it is possible that fungi tissue could provide a functional behavior when organized in an intelligent way in a much larger system. The material's behavior under given environmental conditions is well understood and characterized, so it's incredibly predictable. The same cannot be said for fungi tissues, as there is a high amount of unpredictability and more inherent complexity to the material that we have.
Okay, so I think that was kind of interesting. What they were saying is within a machine system, there's predictability, and that's what's required for the computation, is that the environmental conditions are generally predictable. But in a biological system, they're not. And so if you imagine they're creating this Gaia fascia, global brain, whatever, that's running largely on a fungal network or some sort of biofilm fungal hybrid system, in order for it to provide meaningful computation, you have to account for the environmental conditions. And so is that where we come in? with our digital wallets, and we're all the agents. Like at some point in the Ukraine stuff, and I can't remember who it was, but there was a platform where people could go out and do reconnaissance, open source intelligence. I'd gone to the dock, and this is what it looks like. Here's a picture right now of the thing on the waterfront. You don't need spies, you just need swarm behaviors of individual people fulfilling little tasks, and then you tile it all together to get the information system. And so
like Pokemon Go for war.
Yes. But maybe Pokemon Go now for the environmental condition of the fungal processor?
Who knows what sort of information could be gleaned from that beyond what there's the one layer that you're going and doing this reconnaissance, but then what other sort of sensors are working in the background to gather additional information.
Yeah.
In changing environment.
All right. Well, that seems to be a key thing if they wanted to create a biological computing beyond the existing, because I think it all already is a computer, but to network it or to hijack it for some other purpose is they need the environmental conditions, which is why you would need a bunch of sensors. But maybe a machine sensor or a nanoparticle sensor is only going to give you a certain kind of information, but it won't necessarily have context or heart or emotion attached to it, or relationality, which is maybe what embodied consciousness with a heart gut thing is supposed to do.
Yet to understand. In fact, mycelium networks apparently have more variability in their voltage spiking activity when compared to animal neural activity, which makes understanding and analyzing these signals even more difficult. But I personally find this quite interesting, as this complexity that we see in their voltage spiking, I think it's what sort of provides the potential usefulness, but also a huge challenge.
So, and if you think about unpredictability, and again, they're talking about fungi, but I think the same could be true for preschoolers with Internet of Things smart uniforms and digital wallets, is that on the one hand, the complexity is a challenge, but on the other hand, it's has the potential. You have a toddler in your life, right? And so you could sort of imagine it's both a challenge and an opportunity in terms of information processing. And so how to maximize the upside and minimize the complexity.
Every day. It's constant every day. It's, what we see and what we're trying to instill, but it's beyond me how a child sees.
Yeah.
But it is fun. It is fun.
Yeah.
So you're 1 minute you're laughing and you're playing, and the next minute you're crying, so you really do have to just embrace
the whole spectrum.
Whatever the fungus wants to do, let it go where it wants to go within reason, right? That's the geometry. No, you can't go outside. It's dark.
So a big push in the field of research currently is in work for original techniques for classifying, detecting, and analyzing the fungi spiking activity, which needs understood much better before useful computational implementations can be attempted. In this experiment from Dr. Greg Gage at his TED Talk, he demonstrates how this mimosa plant sends an action potential across the plant when a touch is felt on its leaf. This voltage spike is the cause of the leaf that then folds inwards. It's then demonstrated how a Venus flytrap produces an action potential when its sensory trigger hairs inside the Venus flytrap mouth are touched. But the cells within the flytrap are doing slightly more computation for the action of this plant. See, the flytrap doesn't want to waste the effort of closing on a false sensor input that may not actually be caused by a fly. Maybe it's the wind or a piece of dust hitting the hair or whatever. So it requires 2 separate touches within an about 20-second window for it to actually close. This experiment then goes a step further to link the Venus flytrap up to the mimosa plant via wires. So when the flytrap produces its action potential from the trigger hair touch, that voltage spike is carried via the wires to the mimosa plant, and it folds its leaves.
So what do you think about that?
Cleve Baxter. Cleve Baxter's like, whoa, what are they doing?
Yeah. But see, I think it's this networked system, right? I mean, it's this idea of a sensor actuator of interspecies connection, right? Which I think probably Baxter would say exists without the wires. You don't need the wires to do that, right?
No, the wires is what was sort of documenting that it's there. There's
the ledger,
the primary perception is what he called it. And so there's some sort of field that's telling these things, or I sent you the one link, glacier mice, which to me
I
is
forgot to
really
get the glacier mice
fascinating.
in there.
you've never looked it up, look it up, glacier mice, and
they're softball-sized mounds of moss, dirt, and rock, and they're often called glacier mice because...
Pretty shocking to see they actually move, sometimes very almost herd-like.
That's right. This colony of moss moves up to an inch a day.
It's still a little bit of a mystery. And so we were thinking wind is what really matters, or they're getting pushed around, or they're just following the fall line of the glacier. But it turns out neither of those appear to be the best explainer of their direction.
The next step, researchers would like to put cameras on the glacier to capture the moss moving and help determine what controls the coordinated herd-like motion of the moss mice.
Essentially in like Greenland, there's these little balls of moss that move in a herd up away from the water. And what is sort of causing them to do that is an intelligence of sorts, for sure. But
wow. And think about what lives
to the
in
rocks.
them, right? There's probably all sorts of little things that live in those balls too, that are sensing.
Absolutely. And they're
their own little microbial communities, their own little like rolling towns.
Are they going to like all link up and create a big giant moss town, or it's just fascinating to look at those and be like, maybe the rocks are in charge. Maybe the rocks are the primal intelligence that's
at a different time
convincing
scale,
the mushrooms
the long now.
in a different time scale. That mineral intelligence does seem like they've got the long game on us.
Yeah. Oh my gosh, the phosphorus, right? Oh my gosh.
Mm-hmm.
Well, and it's interesting too, the whole triggering and thinking about social media, because I will admit I'm not great about, I let myself be triggered by things. I'm trying to be better.
It's hard.
But often, that comment, I need to talk, I need to explain about what that is or whatever. And so it's interesting because the sensitive plant has a more immediate reaction, but then the Venus flytrap needs two, right? It needs a confirmation. So there's levels of triggering. And then probably the system will know how to trigger, just like the don't use your educational savings account to get an abortion. They'll know the trigger point to enact that. And then if you link it, if you create established energetic pathways, whether they're man-made and mechanical or existing morphic fields, you can create a cascade of reactions that just,
Yeah.
It's wild.
Get all the fly traps, yeah.
So you can start to imagine the complexity you might be able to get when linking well-understood complex voltage signals together with a far more complex organism such as a fungi.
That kind of looks like a noosphere or a Gaia fascia.
But the fungi science clearly has a long way to go before you are plugging in a fungi compute card into your spare PCIe slot in your gaming PC.
Computers have these components called resistors. They regulate the flow of electricity. They're the bits that switch between 0 and 1 and help the computer carry out calculations. A computer has millions or billions of these things, all switching back and forth depending on what electrical charge is running through them.
So just thinking about that with digital currency, right?
Mm-hmm.
A memristor is a resistor that can remember the position it was in when you stop running electricity through it. Think about that. A computer that when you lose power remembers exactly what it was doing and instantly goes back to it.
That sounds like tardigrades and reminds me of the Long Now Foundation.
Yeah.
I don't know why,
right.
But that's what that's.
Well, the thing is, if you had a digital twin that was logging everything up to a certain stopping point, right, and then you could go back. Because again, you're sort of a time machine. When Cesium and NVIDIA, Rev Labardian and like the Chronos guy are saying like, oh, we can get all of the old data and make predictive analytics to steer towards certain futures, like examine alternative futures and pick a future. It feels like what he's saying is also has a time component to it, or a many worlds theory component.
Or we need a way to like record all of the memories of a person and other, to then put to the twin, and then but we need to be able to make those memories survive by desiccating them in some sort of wetware situation and then rehydrating them later.
That is way more foolproof and energy efficient than anything we have now.
I do think it's interesting that his t-shirt is audio equipment, stereo speakers, and it has a little bird on it. Which is
put a bird on it.
But that's magnetoreception, right? And then that's the acoustic stuff.
And then the butterflies in the background.
Oh,
you know,
yeah.
I like the little objects, you know, the little, it's all just a coincidence, I'm sure.
Yeah, I'm sure.
But this was the one that was from over 10 years ago. So
right,
was,
living computer
the first one I found.
slime mold. Yeah.
Yeah.
The future of computing 10 years ago. So I guess, hello, we're here.
Yeah.
So the problem with memristers is they don't technically exist. Some are in the works, but nobody can show anything off just yet. But enter the slime mold, the beautiful, efficient slime mold. You run voltage through it and it reacts. It sort of...
You run voltage through it and it reacts, right?
Just juice it, you know? Like, what else are they doing like that? Just put some voltage in it and watch what it does.
Right. It braces itself, and it does it in the same amount for the same voltage every time. And it remembers the last voltage that went through it. It stays in that position. A single-celled, naturally occurring memristor. Pretty nuts. So why not use it in computers right now? Well, it's a living thing. It's got a lifespan. Can't be in a permanent computer. The team thinks they could put metal nanoparticles into the slime mold and then let it draw out circuits before it dies.
And that's what Stephers was sort of pointing out.
When he said it like that, like in what you said previously, it's like, you know what it reminds me of is what they used to do to patients in psychiatric hospitals, electroshock therapy. You know, and you're like shocking the slime mold until it remembers correctly, like, right. You know, as a form of psychic driving, right? Which is the old MK Ultra psychic driving. We're gonna shock you and shock you and shock you and then reprogram you so that you remember things the way we want you to, just in case we need to use you in a specific situation.
Right.
Behave, slime mold, behave. You know?
Oh gosh. Or we'll put you in the dark corner of a cave and let you try to find your way out.
Yeah, you pick which one do you want.
Right.
I mean, you know, like if you're in the psychiatric hospital and you've been there a while, like you might choose voltage therapy so you can get out because, you know, the cave, you've been in there a long time. But
well,
yeah,
it is interesting to think about getting out of the cave just in terms of the whole platonic thing too.
Yeah, definitely. There's the slime mold is looking at its shadow, you know, trying to look behind, but yeah, I just can't.
Imagine a cave that needs lighting. You put the mold in the darkest part of the cave and it grows out, finding the most efficient route to the surface. And when the mold dies, you've got all the wiring you need to efficiently light and power that cave and monitor brightness. Why do we want to do this? Why do we want living computers? Those neurons calculate electrical grid needs faster and more accurately than our current network, and they're super cheap to make. All this stuff is. We get computers as small as the ones we make now without the exorbitant costs of manufacturing them. Living things are resilient and self-replicating. A tiny single-cell computer placed into a human being could help control and regulate health problems at a genetic level. Eventually, we could have inexpensive, self-repairing systems running everything on our planet and keeping us in optimal health. Or a spooky, super intelligent slime overlord that controls us from inside our bodies.
That's what you said. That's what you said.
We might already have
super intelligent slime mold moving us around.
Moving us around. We need to go over there. Yeah.
Or it could be both. You know, we're working with the slime mold.
We're super healthy, permanent longevity exoskeletons for the interdimensional biofilm. Yeah. I mean, and you're right, this is 10 years old. So again, this is something that unless you know to talk about it, again, I'm not saying that, this just may be the brain box that I'm living in right now. I'm not saying that I'm outside of the brain boxing, but I think that when you're in the information flow feed, everyone's like, let's talk about biodigital convergence or transhumanism, right? But to what end? And I guess that's sort of where, and maybe we won't ever know what the program is or what the puzzle we're trying to solve or the pattern we're supposed to see or the nature of the performance we're enacting in our live action role play. But those are the kind of questions I'm interested in figuring out at this point because, oh my God, there's transhumanists. Well, what does that mean when ultimately 10 years ago, they're already talking about the future of technology is squishy organic stuff? If the nanoparticles are all made out of quote unquote organic stuff, how are we having this conversation about technology? Which again, I was there before, nature versus technology. We want nature. Well, what if the technology is nature?
Right.
And then it gets complicated. I mean, I'm not against nature. I like nature. I'm planning on having a really nice garden with native plants and things and putting my hands in the soil. I'm not really good at with the garden gloves. The house inspector, he's like, well, we have a lot of black widows down here, so you should garden with gloves. Like, okay, get to know your home state microbiome, brown recluses and black widows or whatever. So yeah, I don't want to be against nature, but how does that change this us against technology conversation? Because it's not so easy when the technology is like, again, the stuff he's talking about is bioengineering and Freeman Dyson. We're going to genetically engineer yeast or whatever to grow things.
The currently existing life forms are not even the snowflake on the tip of the iceberg of possible life forms. Many more things could exist in nature than there currently are. So if you just take that approach, then nature appears in a radically different light. It's suddenly this field of possibility, organized mechanical processes and technologies that you as engineer could enter, could participate in, and could produce organisms that currently don't exist in nature, but that easily could exist in nature. And you look at the 20th century, where technology and industry was sort of the anti-nature. You say, wow, there might have been a misunderstanding of technology. The problem is not less or more technology. The problem is the terms in which it was built. It was unfortunate. It was a misunderstanding, so to speak. So that strikes me as one extremely powerful tool for thinking about climate change, replacing technologies by biologies, so to speak, or with biologies.
That they wouldn't normally do, which I'm against. Do you see what I mean? Like it gets complicated.
Oh yeah, very, very much so, because then no matter what you try to say, it sounds like you're attacking, right? Yeah. And it's like, well, there is like, I get a sense that human capital is a good way to phrase this, that,
and natural capital, right? And
natural capital and a hierarchical system or a caste system definitely feels like it's in place, and it has been for a long time. And so within that hierarchical caste system is, Plato's allegory of the cave. Like we're all sort of chained looking at it, and the shadows are dancing, and the shadows could be technology, they could be nature. It doesn't really matter because it's scary. Whatever you're looking at is scary, and like this is scary because
there's
I do feel
that
I'm chained and I can't turn around to see what the heck is going on, and I really want to figure out what the purpose is, but without it being like so. The past is a good indicator of what we're in now, if we believe in that cycle. And so the vision
unless it's
of
nonlinear time in many worlds, and we can jump to a different timeline. I don't know.
I'm all for a universal aristocracy, right? We should all just be aristocrats and playing around with our magic technology, and but that actually wouldn't be feasible, because what one person wants and what another person wants are two completely different things. And so it's a lot to unravel. There's a lot more deeper philosophical questions with it. But when we look at dark ops and the Athenian superstate and any sort of military aspects, I do think that there's a certain darkness or they're not trying to bring about harmony for everyone in the way that we might want as individuals when we don't know what game we're in.
Yeah.
There's a control module, I think. Does that make sense?
Well, I think it's control and optimization, but to what end?
Yeah,
so in
to what end?
That 3-hour clip, there's some really good chunky things from Stafford Beer, the cybernetician, right, who was working under Norbert Wiener, working on the cybernetics, and he's talking about the lighthouse and steering, right? And you're staying the course. And then the trick is, who decided that the lighthouse was the destination? Who got to place the lighthouse in what direction? And again, I think for the vast majority of people, if your current situation is reasonably, if not comfortable, not fraught with active distress, you're willing just to be in the boat, because that you're with the boat with people you care about, your loved ones, your friends, whatever. You're not interested in getting out of the boat, because it's okay where you're, and then there's a smaller percentage of us who are like, what the heck is this boat? You know, where are we going? And they're like, can we drop them off at the dock?
I wish we could just give her a life vest and she can swim, you know, like, yeah.
And it's hard being the
like,
one to be like, wait, where are we going? Mohita said to me, you know, before, there's a small number of people who are really engaged with these deeper questions about the social contract. It doesn't make those other people dumb or bad. We're just in a different place. And, you know, and it's hard kind of questioning the vote, but once you start to question it, you can't go back to pretend that you don't know those things, you know. Like, you just have to keep, it doesn't feel like you can rewind. I don't know, maybe some people would be better at rewinding than me.
Once you can see, you can't unsee.
Yeah.
And then that, you know, and there is a lot of within the 1 billion people on the planet who are sort of steeped in technology and materialism versus the 7 billion people on the planet who live, you know, with a lot less.
Yeah.
But we want them all to have a blockchain ID, those 7 billion people. Some of them don't even have electricity, but they have smartphones and solar charging equipment, you know. And so getting that doesn't feel like those people are being even given the tools to have a conversation, you know, or, you know, there's so many other problems that we could be focusing on. And so I feel that's where, like, some of the technology stuff does feel predatory.
Yeah.
So it does feel
and
evil,
I don't mean to say that, like, it's not. I mean, because clearly I know the impact bonds, you know, putting kids on block, you know, gambling on all, it isn't right. It foundationally isn't.
But right and evil and good and bad and those sort of, like, that bicameral, you know, that there opens a whole bunch of ethical dilemmas in that. And I think it was Marshall McLuhan, or it might have been Terrence McKenna, but it was one of the two. I was like, technology is not something that I can even understand personally. Like, I can understand what it does to a point, but I don't know how to build it. You know, that takes a very specialized person. And the human doesn't really even know the full potential of the technology. And I think it was McLuhan who said, like, when they take those psychedelic drugs and this new sort of chemical interface is when they'll fully understand what technology is supposed to do. And, like, McKenna considered it a prothesis of us. Like, it's like, you know, it's like a microscope, a new tool. Yeah. And, you know, so how we feel about that. And I feel that that's really where I'm kind of in, is like, well, if we keep doing what we've always done, we're going to get more of what we've got. And it's going to keep leading down this path where everything is, you know, at what point do you know, that's the free will conversation, I think, too, on the peripheral right there. What point do we get to make our own choices versus we don't have the freedom to choose what the choices are? We don't know we don't get to choose what we want. You know, we can pick what we want, but we don't get to decide.
There's a menu. Here's what's on the buffet today.
Yeah.
You know?
Yeah.
And
you wouldn't even think that there's another menu.
Yeah.
This is it. There's no other food options. You're like, ooh, you know, you've never considered even eating, you know, or it's just, my uncle used to say, you know, vegetables come from Safeway, which is the grocery store. And I'm like, yeah, well, how do you get to the store? You know, and, like, it's just this whole disconnection of what we even are anymore. But
I think that they'd like to integrate us. I think the fungal, I think that's what, well, so let's get to the kombucha. Let me just keep going.
Let's get to I know, I think we're sort of running out of time. I don't know what time we're going to kick me out.
So here they're just talking about experimental physics using mushrooms to make this wearable tech, and that they used this mushroom skin and integrated these batteries that were powered with humidity and had Bluetooth connection. So this is, again, organic biocomputing, and that this particular fungus they use because it can absorb all this moisture, which is going to be part of the, you know, running the batteries on the moisture. But think about the intelligent water. And it has high thermal stability, and it has all these cycles, and it's going to be super organic, so we don't have to make the bad old technology. We're just going to make the new mushroom wearable technology. You know, sustainable batteries. And again, I'll just manage that Vantage Point Capital that Bobby was involved with was very much involved in the battery space. I don't know if it was fungal batteries, but like sustainability and batteries. So So that's the answer. And there wasn't any voiceover on this, so that's what I just read. This is from Mashable, What If We Could Make Electronics from Mushrooms, from November of 2022. So this is the last one here.
And take a look at that beautiful dress design.
So this one is called Kombucha Dress in the News, Good Day Sacramento, from 2017. All right, a blast from the past.
And specifically for National Geographic, now you've partnered up with UC Davis for the last couple of years. You're working to create something really special and unique.
Yeah, it's sustainable vegan leather
Sustainable vegan leather that's really squishy.
Is actually grown from kombucha live culture. So
live culture.
I grow and sew vegan leather from cellulose that's created from bacteria.
Okay, so that's what you're looking at right now. This is a mother. So Sasha, why don't you hold that up for everyone so that they can get a really clear idea. It looks gross.
It does look gross. It's very squishy.
I mean, there's no doubt about it. It looks slimy. And that's exactly what it feels like. It's pretty disgusting, but it's phenomenal. And
now, I will just say that this is going to be the answer to globalization, right? Is relocalization with local bioreactors, with fungus. The Berggruen Institute, Nicholas Berggruen is all about this stuff. Having these localized, decentralized bioreactors in your Freedom Cell community with your vegan leather.
I'll first start by talking about synthetic biology. The primary research project I'm spearheading revolves around synthetic biology, and I have joined the lab of Drew ND at Stanford University's Department of Bioengineering to do so. Much of the lab's work is devoted to build-cell efforts, the primary purpose of which is to engineer novel forms of cellular life and from the ground up if possible. They desire operational mastery of living matter, which does convey with it something of the classically modernist engineering approach to nature, and that mastery could be interpreted as carrying that trope of control. Yet the concepts of living matter, of nature and of natural process, and of technology that are implicit to these synthetic biologists' actual practices and designs appears already to me to belie the dominant man, the engineer as master of nature framing that the bulk of many other of today's biotechnologists have unreflexively inherited from our engineering predecessors. With Drew and all the members of his lab, there's such an abundance of playfulness and humility, and also an interest in collaborating with biological parts and processes. And as they guide me into the world of synthetic biology, we're beginning now to think seriously together how mastery could be pursued without an attitude of control, but rather by forging a spirit of collaboration with living matter. And these conversations are blowing my mind.
it could be the leather of the future.
Exactly. It's a new sustainable, non-violently produced leather.
Non-violent leather. I don't know how the kombucha feels about that.
That is very environmentally friendly. It doesn't take as many resources as growing a cow. So
right. A lot of much different resources and much fewer resources. A lot less water.
Product. You can actually. This is all food coloring, so it's completely natural. You could.
Now, the food coloring, that's probably that mycelial or melanin, fungal melanin that Stephers was talking about, because that's the fungal coloring is what they're saying is sustainable. So it's not only the kombucha part, but probably also whatever fungus is embedded in the color too.
Actually eat your dress if you wanted to.
Well, you could. Yeah, I mean, no, that's certainly one way to do it.
I'm working with UC Davis to see whether the actual probiotic benefits of...
Now, notice her necklace has all the triangles. So I just do feel like that this Pythagoreanism is coming through too.
Use of the kombucha can be transdermally absorbed by the body.
Okay, so did you hear that?
That's the key part of this, Sean? I think. The dress has a probiotic imprint, so you can get your probiotics when you wear the, it's just like Silence of the Lambs. It's like it puts the kombucha on its skin or else it gets the probiotics again. It's like, what's going on here?
Yeah.
And
they've got little sandals there. So can you imagine the Wildflower Montessori pre-K Internet of Things shoes being melded with probiotic footwear? How that works, thinking about the acupressure and the pressure points in your feet and having it interact with
well, reflexology, right? Like the reflexology of there's just all these little
pressure points in your feet with the probiotic shoes.
Your skin? Oh my God.
Probiotic dress.
That is phenomenal. Okay, so I'm going to swing on over here to Chelsea, who's one of the students who's worked. Come on over here, Chelsea. Come on over here. Why are you wanting to be a part of this program? What is your vision?
And her dress is very crystal latticey, don't you think?
Yeah, well, she didn't want to wear the
fake leather
the capucha.
I think this is super exciting to see how we can change the textile and the manufacturing industries by creating more sustainable designs through science, design, and art together.
See, science, people. It is sexy. Science. And I just want to show off Erica here for just a second. We've got a couple of dresses that you're going to have to stick around to check out in the 9 o'clock hour. And we're going to be talking with Erica a little bit more just about how the dress feels.
She should wear that dress right there.
As I drink kombucha.
Oh, yes, she should.
And
I know.
I mean, a multi-purpose outfit. If I can eat it and wear it at the same time. If I'm on the red carpet and I'm hungry and I can just take a bite out of my outfit and still look fly and it's environmentally friendly, like
great on her, exactly.
So that's sort of the end of it. I mean, and I have to say, it's sort of painful once you start to realize what's going on with this stuff. When you see these news shows and how they're just positioned to frame out these networks. I mean,
little issues,
Yeah, I mean, just introduce it to consciousness, and probiotic clothing.
Inoculate the consciousness with the spores of sustainable fashion and allow it to spread through the group mind.
Yeah.
And I mean, this is like way beyond the trash fashion where people were taking trash and kind of like making clothes out of it.
Yeah.
And I think the kombucha fungus, or one of the kombucha, I want to say that's what is able to eat the plastic too. I don't know if that's the right one.
Oh, wow.
But there's like the whole garbage eating fungus to reduce landfills and plastics and whatnot. And so that would be.
Well, yeah, you could eat the landfill and make the leather.
Yeah, at the same time, Yeah, so as it's eating through the garbage, it's spitting out tomorrow's fashion designs.
Wow. Yeah. Well, I mean, and you think about the whole circular and cybernetic and cycles and information, how the information gets consolidated through the systems. So, well, I know you've probably got to go, and at some point, we didn't get to Julian Gresser and the intelligent heart stuff, and that's a whole other piece. We'll touch on that too, and the idea of like heart entrainment and that being part of emergence and sort of the fungal. What was Robin Wall Kimmerer? What did you call it? Popoi? Yeah, the indigenous or Ojibwa word for the force that pushes the mushroom fruiting body up from underneath, overnight. The idea of like the heart manifesting these different intentions. And I think the thing about some of this, these fungal networks, is there's something called quorum sensing, Quorum, I think, quorum. And I think that is going to be linked to consensus, the consensus with the YCO, like the Lubin consensus with Ethereum, is that in addition to being ant agents, we're also fungal agents, mycelia components. And through quorum, like sensing and voting, quadratic voting, we will emerge something. I don't know what the thing is. So anyway.
Well, next time we get together, I'm sure we'll figure it out.
Well, yeah. Well, I don't think we're ever. I offer no promises that I know what's at the end of this road.
No, I agree. This was great. I really appreciate the time to sort of do this first one-on-one Sean and Allison conversation, and
And of course, just to acknowledge Stephers too, because like I said, we have sort of this three-way conversation. I just want to acknowledge sort of the shared intellectual collaboration.
Yeah, there's a lot going on behind the scenes in all of our lives, and I value your work and the platform.
It's our work.
Our work.
Yeah.
But you've laid the you've created the geometry, so to speak, for us.
Well, and we're testing it.
Explore space.
Part of it is there's some frameworks, and it's kind of like what you have with Bell's Mountain. Like, you have some ideas, and then you test things against it. Does this uphold it, or does this make you question it or refine your view of it? And I think that's what's, to me, it's, if I'm the slime mold of the Adrian Tchaikovsky book looking for novelty, it's like, what's the next thing? And let's compare, let's hold it against each other and say, does this reinforce or undermine, right? And then revise. Because there's not, I really appreciate that about you and Stephers, is there's, you know, and Lynn and Leo and Jason and, you know, Cliff and the other people who've been parts of things, you know, up to a point, is that to have the ability to sort of compare and revise and refine and then keep adding, it's not, anyway.
There's no end. Yeah, there's no end. It's just getting.
But it's hard to find community that's interested in doing that. Because a lot of people just want to get in the boat and go to the place with the people they like, you know?
Well, the boat ride is going to suck. It's going to be a lot of talking. You're going to be, you know, bring some snacks, you know, stay hydrated.
Yeah.
We'll be good.
All right. Well, good night, everybody.
Great. Good night.